All right, welcome to Unit 15, which is going to basically be the last unit of the year and is going to be the building blocks for those of us moving on to calculus, whether it's at the high school level next year or at some point in college. Regardless of when we've taken it, you've clearly proven to me throughout this year that you're capable of it, and you're clearly capable of some really high order thinking, and I'm very proud of you guys. So, having said that, recall that finding the limit graphically means the following. So if we are looking to find the limit of the limit as x approaches 2 of x squared plus 3x minus 10 over x minus 2, remember that we want to find out what's happening when we go towards 2 from the left and from the right. And what we'll see in this situation in both cases, it approaches 7. So we need to remember that in order for it to be a limit, it must approach the same value from both sides, because a limit is the y value the function is approaching at a given x value. It's okay if it's an open circle, because we're not getting to that value. We're getting very, 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 very close to that value. So some steps to finding limits analytically that we need to remember as we move through this lesson is direct substitution can work, meaning put 2 in for x, and then simplify or try simplifying and then try direct substitution, such as factoring and canceling, and rationalize if you see square roots. So what this means, if we just did direct substitution to start, we would do 2 squared plus 3 times 2 minus 10 over 2 minus 2. And we'd see we got into a situation where we would get 0 over 0. It didn't really help us. But sometimes if we were to factor this, if we took x squared plus 3x minus 10 over x minus 2, and we factor that to, let's see, what multiplies a negative 10 adds to 3. That would be x plus 5 times x minus 2 over x minus 2. Okay, then we see these cancel. So we did our factor and cancel. All we're left with is x plus 5, which if we put in 2, look what we get. We would have gotten our answer a different way. Okay, so that's just kind of where we're going with this. You do not need to, at this point, know direct substitution or step 2 to find the limits. This is just an introduction. If at the end of this video, you're able to understand what I was doing going from left to right in the recall part and the definition of a limit, you're already in a good spot.